No, ma'am.
No, are you available? Or any other day? I'm comfortable on Tuesday also. Any moment, any time in this week. Let me know both. Just wait. I'll give you time till the time I'm discussing this parallelogram law. Then we can have it. Just keep a day and a time in your mind, morning time, because if the vacations are going on, let's use it, right? Let me ask Abir also. She is joining. Then I'll start with the class. Abir has joined. Abir, am I audible, Abir?
Yes, ma'am.
Okay. Abir, I was discussing with Ali and Abu Bakr that we are still on vectors and we have to complete this chapter quickly so that at least from the next week we can start with laws of motion. Not even the next week, the coming week, we can start with laws of motion. At least we should be at laws of motion. So I want to arrange an extra class for all of you in the morning. Not tomorrow. It's not compulsory for tomorrow. On Monday, Tuesday, Wednesday, Thursday, any day when you are comfortable. I think Tuesday, if Monday is also fine by all of you, then Monday we can have a class 1:30,
Yes,
1:30
Monday.
timing Monday if you all are available. 1:30 p.m. KSA timings.
Yes, ma'am. 1:30.
Just a second, class. Just a second. Okay, class. So Monday, I think 1:30 p.m. KSA timing is fine because I want to take a little extra class. 1.5 hours, at least 2 hours, or I'm comfortable on Tuesday one. But I want every day if we can have the class so that syllabus is a little at its pace. All right, just let me know. Monday, 1:30 p.m. If you have another time, we can follow that. Okay, let's start with parallelogram. I want to complete this parallelogram law today. See, parallelogram law of vector addition is all about a parallelogram. Do you all know? See, I'll tell you that also. So parallelogram law of vector addition is all about two vectors getting added together and their resultant we get. So why parallelogram, that we'll see. But first, what are the criteria? Firstly, understand that it adds two vectors only. Suppose v1, v2, v3 are there. So first it will add v1 and v2 and give its resultant over here, resultant 1. And then at the end, v3 with this resultant. This will give the final resultant. See, one resultant here, then this resultant with this v3, it will give a final resultant in whichever is the stronger direction. That I'll tell you, that you will see in detail. But this is how this is followed. Parallelogram law. Second, vectors should have the same starting point. They should be co-initial, means this is the head, this is the tail. So tail and tail only should coincide, not head or tails, not head or heads, only tails and tails. These vectors which have the same initial and starting point, these are called co-initial vectors. All right. These vectors, this scene, if you see, they have the same starting point. So such vectors are called co-initial. So same starting point. But here in this is just an example. Co-initial are these two. All right, these are the co-initial vectors like this. Then only your parallelogram law is valid. And this I was telling. A parallelogram, what all things you should be aware. Firstly, all the angles make 360 degree. That's a common property of a quadrilateral. Opposite sides equal, opposite sides equal in the form of and all the sides aren't equal because that will form a rhombus. So these two opposite angles equal, forming 360 degree. This is what is a parallelogram. So opposite sides are equal and parallel, equal and parallel. Write it till here, then we'll start with the derivation and understanding of parallelogram law. Write it.
Done, ma'am.
Yes, Alina. Am I audible to you? Alina?
Yes, ma'am.
All right. So, Alina, we've started with parallelogram law. So, there are two conditions of parallelogram law. First condition is that it can only add two vectors at a time. So like here there were three vectors v1, v2, v3. So first it will give us the result of v1 and v2. Then later on the resultant with the v3 can give us the final resultant. This is one of the properties. Just take a screenshot because this much only was done before you have joined. And second is this, that vectors should have the same starting point. Tails and tails should coincide and they should have a same starting point. And such vectors which have the same starting point, these are called as co-initial vectors. Okay, Alina?
Yes, ma'am.
All right. One more thing, Alina, before you have joined, we were discussing one thing that I want to have some extra classes for you, at least this week. Then after that, I'll not take your extra classes in the morning because your vacations must be going on. And I want the classes so that at least we complete quickly with the vectors and projectile motion because we are lagging a lot. We have to complete this chapter so that we can start with laws of motion at least. Then our stable will be stable. Syllabus will be stable. Okay. So let's see Monday or Tuesday. We'll discuss about this because tomorrow also we have time. Finally, I hope you're available in the mornings.
Yes, ma'am. I'm available anytime.
Okay, okay. Okay, class. Now, what is exactly parallelogram law? Okay, just this was also left, no? This you can write along later. Just understand what is parallelogram law, then I'll give you time to copy the above part. See, parallelogram I have shown you, right? These are the sides of parallelogram. And if I join these two, that will give the diagonal of the parallelogram. So see, if two vectors are in such a manner that they are representing the adjacent sides of parallelogram. What are these? These are basically the side, this is the side of parallelogram. And these two are representing adjacent sides of parallelogram. Then their resultant, see if I complete the parallelogram, it will be somewhat like this. Then their resultant will be given by the diagonal of the parallelogram. This is what is the law. Two vectors, the diagonal will give the resultant. This is vector 1, this is vector 2. This is it. This is the law. So it says that if two vectors acting at a point are represented in magnitude and direction by the sides of parallelogram drawn from the same origin, then their resultant can be represented by the diagonal of the same parallelogram. This is the law. This is the law in theoretical form. We'll do the derivation. So there are 3 steps. First, we have to do the geometrical construction. Then we have to find out the magnitude. And lastly, since this is a vector quantity, we have to find the direction. So I'll start with the derivation. This derivation is very important, but first all of you start writing from here. Then I'll start the derivation. Done?
Yes.
Yes, ma'am.
Yes, ma'am.
So first step was geometrical construction. Geometrical construction means we have to complete wherever you see such coinitial vectors, we'll see them, we'll form the parallelogram. And then the resultant will be like this. So at least we now have an idea where the resultant will be formed. Now class, just for the derivation purpose, we have to drop a perpendicular on this. All right, let me just name this as something. This is T, this is S, this is Q. This angle here, this is theta. Why class? Because they also subtend an angle theta. And these are alternate angles. No, these are corresponding angles. So this will also be theta. Understood class? Both the vectors have theta angle between them. So this is corresponding angle. So it will also be theta. This is just for the derivation. This is just for the derivation. All right, class. Now see, what all things are present. See, firstly, OT. Here, OT means vector B. I'm writing so that when we'll be discussing, this won't be new. OQ means vector A, right? QS is also B, right? Because they are parallel. So QS is vector B. Then ST, this is vector A because these two are parallel, right? If these two are parallel, these two are also parallel and equal. So ST is equal to vector A, right? And lastly, this OS diagonal. This OS is equal to the resultant diagonal. Fine. All clear till here? This is the first step. Let's start with the derivation. Now look, what is this triangle OSN? This triangle, this, because this is 90-degree, making angle of 90-degree. This is a perpendicular which we have dropped just for the derivation purpose. All right, so this is a perpendicular that has been dropped. So this is what it is, right? Just to show you so that we can have the derivation done. Now look, in this figure, if I apply Pythagoras theorem, then this diagonal OS will be equal to under root ON square plus SN square, right? Hypotenuse square is equal to base square plus perpendicular square. So this is equal to ON whole square plus SN whole square. Fine. Now look class, one thing. Just look at this ON. How is this ON constructed? This ON is constructed by OQ plus QN. So I am going to replace this ON square with OQ plus QN whole square. Then I'll put this SN square in this root. All right, class. This is my first equation, which I want to find out what are all these things. But before that, have a look here in this small, this extra perpendicular triangle which we have formed, this one, QSN. Have a look here. This one. This I have drawn here separately. Now see, in the triangle QNS, means this triangle only, if I write cos theta, what is cos theta? Base by hypotenuse. So Qn by Qs. Qn by Qs, right? What is Qn equal to then? Qs cos theta. Qs is the B vector, right? Qs is the B vector. Qs is the B vector. So we can write this as Qs cos theta or B cos theta. Just give me a second, class. Yes, class. So this is B cos theta. So this is our second equation. Fine. Now in the same triangle, in triangle QNS, if I write sine theta, so this is equal to Sn by Qs, right, class? So what is Sn equal to? Qs sine theta means B sine theta. So this is my equation 3. If I put 2, 3 in the first equation, means this value of OQ we already know. OQ, this is vector A already. So we know this already. OQ. QN we have got and SN also we have got, right? B cos theta, this is B sine theta. And what is OQ? OQ is A. Let us put everything here. So here when we are writing this, OS, and what was OS? OS was the resultant. Remember? OS is the resultant. So the magnitude of the resultant, this is A plus B cos theta whole square plus B sin theta whole square under root. This is what we have to solve now. All right. This is A plus B whole square, right? This is A plus B whole square. This I'll discuss. First, let us just use the, or do one thing, class. It will be very lengthy for all of you to catch up then. Till this, write it. Write it first so that all the doubts are getting cleared then and there. Write it from here.
Noted, ma'am.
Okay, yes, so done till here. Now see, we'll open this a square. This becomes b square cos square theta plus 2ab cos theta 2ab cos theta. So a square plus b square plus 2ab cos theta, and this also becomes b square sine square theta. All this is under root. So look class, one thing, just have a look at b square cos square theta and b square sine square theta. So this will be, if I take b square common from here class, so it will be b square, and this will be cos square theta plus sine square theta plus 2ab cos theta. Now class, cos square theta plus sine square theta is an identity which is equal to 1. Cos square theta plus sine square theta, this is equal to 1. So what are we left with in the end? Final formula of magnitude. This is under root a square plus b square plus 2ab cos theta. This is the magnitude. This is the magnitude. So what are the terms here? This is the important formula here. What is R here? It's the magnitude of resultant. What is this? First vector. This is second vector. And theta is the angle between two vectors. Angle between the two vectors. Angle between the two vectors. So this is the magnitude. Now class, when we are talking about the direction, without this, the direction would be incompleted, right? So last step, step 3 for the direction. So we just mark beta here. All right, always mark beta, that gives us direction. So this is that beta which I have drawn. Now I will write tan beta here. Tan beta is Sn divided by On. And this is Sn. What is On? OQ plus Qn. Now we have already derived all these terms. So finally, tan beta is equal to B sine theta. OQ was A. This is B cos theta. This is the direction. Write it and complete the derivation. Mark this important class. This comes in the exam.
Completed, ma'am. Noted, ma'am. Done, ma'am.
Class, this is the magnitude, this is the direction, but we write the angle in this way whenever we have the direction. There is inverse trigonometric function. For example, sine theta is equal to half. So I will write theta as sine inverse half. If tan theta is equal to 1, so theta I will write it as tan inverse 1. If tan theta is 1 by root 3, so I can write it as tan inverse 1 by root 3. If tan theta is 3, I can write theta as tan inverse 3. So similarly, whenever you get the direction, write it like this. Beta is equal to tan inverse and whatever angle you have got, if you don't know the exact value. We'll start with this question. Write it down from here. Look here, class. Two forces are given, 1 Newton and 2 Newton, separated by an angle of 60 degrees. So first step is that we construct the parallelogram. We form the resultant, and this will at the last become beta. So resultant will be f1 square plus f2 square plus 2 f1 f2 cos theta. Okay, Alina, I'll show you. Just wait. So this will become 1 square plus 2 square, 2 into 1 into 2 into cos 60 degree. Right, class? So this is 1 plus 2 plus 2 into 2 into half. So this is cancelled. So this becomes 5 root 5 Newton. This is the magnitude. It's just the magnitude. For the direction.
Ma'am, but 2 square should be 4.
Okay, sorry. Yes, it will be 7. This is 4. This is 7. Now, when we are calculating tan beta, it is B sine theta. Now, how do you decide A and B? The angle, the axis with which the angle is made, this is taken as A, and the other one where angle is not there, it is taken as B. So 1 sine 60, 1 into sine 60 degree divided by 2 plus 1 into cos 60 degree. So this you can solve here. This becomes root 3 by 2 plus half. Right? This you can solve further and let me know whatever is beta. Write it. This someone wants. Just update me in the chat column.
Ma'am, done.
See, two vectors are here, 3 Newton and 5 Newton. Now see, angle between them is 90 degree. So class, when we write the resultant f1 square plus f2 square plus 2 f1 f2 cos 90 degree under root. So cos 90 degree becomes 0. So this entire term becomes 0. So for perpendicular vectors, this is directly under root f1 square plus f2 square. Right? So resultant will be under root 5 square plus 3 square. So this is 25 plus 9, which is 35, 34. This is 34. And for the resultant also, see, when we are writing the magnitude tan beta, B will be, if this is the resultant, this is beta. So this is A, this is B. So B is 5, A is 3. So B into sin 90 by A plus B cos 90. Here also this will be 0. This is 1. So it is directly B divided by